Alright, so today we're going to look at the unit circle. So the unit circle is pictured there in the middle, and an important thing to note about the unit circle is that it has a radius of 1. Okay. Now, we're going to use special triangles to describe various instances around my unit circle. And if you remember from your geometry days, we have the 45, 45, 90 triangle and the 30, 60, 90 triangle. Now, these triangles give us special values around my unit circle, okay? And for the triangle side lengths, we have 1, 1, and then the hypotenuse is the square root of 2, and then square root of 3, 1, and 2. Now, in order to use these special triangles inside of my unit circle, right, I need to make the hypotenuse equal to 1. And after we kind of talk about the different reference angles here, we're going to talk about changing that hypotenuse to 1 and what that would ultimately look like for my side lengths. So, starting off here with my 45-degree reference angle. So, 45 degrees would put me here, right? It's going to split my quadrant. Okay, so your 45-degree reference angles, those are going to split the quadrant in half. So that rotation there would be 45 degrees. The other splitting of quadrant 2 would put me here. Okay, and that would be 135 degrees. If I split the third quadrant, that puts me there at 225. And splitting quadrant 4 puts me here at 315. And I'm getting those degree measures by doing the 45-degree reference angle, right? So 180 minus 45 would give me 135. 180 plus 45 would give me the 225. And then the 360 minus 45 gives me the 315. All right. Now, a 30-degree reference angle would be this right here. Okay. And the 30-degree reference angles are the measurements closest to the x-axis. So there's my 30-degree. 30-degree reference angle in quadrant 2. 180 minus 30 would give me the 150, and it's the angle measure closest to the x-axis. So that would be 150 degrees of rotation. To 10, right, 180 plus 30. And then quadrant 4 would be here, again, closest to the x-axis. 360 minus 30 would be 330. All right. We're going to do the 60-degree reference angle next. And the 60-degree reference angle are the angle measures closest to the y-axis. So that would be this guy here. So closest to the y-axis. So quadrant 2, 180 minus 60 would put me at 120, which would be this guy. Quadrant 3, put me here at 240, right? 180 plus 60. And then the last one for quadrant 4, closest to the y-axis, 360 minus 60 would be 300. All right, the last angle measures that we're going to talk about are my quadrantal angles. Remember, your quadrantal angles are your multiples of 90, right? So here would be my first quadrantal angle, 90 degrees. Okay, starting at 0, right? Here's 0. Over here, this would give me 180 degrees of rotation. Add another 90, that puts me at 270 degrees. And a full circle would be 360. All right. Now, that's the degree measures that we're going to focus on. And to give you an idea of the radians that go with these reference angles, your 30 degrees reference angles, those are your pi over 6s on the unit circle. Your 45 degree, those go with our pi over 4s. The quadrantals, those are your pi over 2s. And then the 60 degree reference angles, those are our pi over 3s. Okay, and we'll talk more about the radian measures here in a minute. So, before we actually get into labeling and writing out the entire unit circle, we need to discuss how we're going to find the x and y values, and those deal with the side lengths of my triangles, my special triangles. So we have to go back and revisit sine, cosine, and tangent. And if you guys remember from geometry, there was that acronym SOHCAHTOA, right? So sine is your opposite side over your hypotenuse, cosine is the adjacent over the hypotenuse, and then tangent is the opposite over the adjacent. So if I look at my unit circle here, okay, and I create a triangle, so there would be theta, it has a hypotenuse of 1, right, because my radius of my unit circle is 1. This point would be the ordered pair x, y, where x is the side length on the x-axis, right, the distance traveled in the x, and then the y is the other side length of the triangle, the distance traveled in the y direction. So if I think about SOHCAHTOA and relate that to sine, cosine, and tangent, sine of theta, opposite over hypotenuse, so y over 1, which would just be my y value. Okay. Cosine of theta would be the adjacent over the hypotenuse, so x over 1, which would just be my x values. And then my tangent would be the adjacent over, or sorry, the opposite over the adjacent, so y over x, or sine of theta over cosine of theta. Okay. Now, looking at the three trig identity or trig functions on the right here, we have cosecant, secant, and cotangent. And these are related. So sine and cosecant are related, cosine and secant are related, and tangent and cotangent are related. And the way we identify them is that we take the reciprocal. So if sine is y over 1, the reciprocal of sine would be 1 over sine which would give me 1 over y. The reciprocal of cosine would be 1 over cosine theta, which would give me 1 over x. And then cotangent would be cosine over sine, which would give me x over y. So it's literally just flipping sine, cosine, and tangent. Now, to get a hypotenuse of length 1, okay, so that my special triangles fit inside of my unit circle, I'm going to have to do some dividing. So looking at my 30-degree measure, okay, I'm going to have to divide everything by 2, which would give me my radius, or my hypotenuse, of 1 that I'm looking for. So this is dealing with my pi over 6. Okay, I would get an x equal to the square root of 3 over 2, and a y equal to 1/2. So looking at my unit circle, okay, I'm going to start with 0 degrees, right? And that has an x length of 1, right, my radius, and a y distance of 0. Okay, so there's the ordered pair for that point. 0 degrees is the same as 0 radians. Okay, so doing my closest to the x-axis, so that first rotation, okay, that would give me 30 degrees, right? And that goes with pi over 6. That's the radian measure that's equivalent to 30 degrees. And using my special right triangle here, I saw that the x value is the square root of 3 over 2. So that's the x coordinate. And the y value we saw was 1/2. Okay. Now let's do that same process for the next special right triangle, so that 45-degree measure. Okay, so now we're going to look at 45 degrees on the unit circle, which would be here. And that goes with pi over 4. So again, getting my hypotenuse to equal 1, right, so that it fits inside my unit circle, I'm going to divide square root of 2. So rationalizing my denominator, I would multiply top and bottom by the square root of 2. So the x would be the square root of 2 over 2. Same thing for the y. Rationalize the denominator, I get the square root of 2 over 2. And that would be my y. So it has an x distance to this point, that is the square root of 2 over 2, and a y distance, that is the square root of 2 over 2. The last special right triangle is still a 30, 60, 90 triangle, but the reference angle here is going to be 60 degrees this time. And we'll do that in this color. So dividing by 2, this time the x is going to be 1/2, and the y is going to be the square root of 3 over 2. So closest to the y-axis would be my 60-degree reference angle, and that goes with the pi over 3 radian measure. And then we just saw it has an x value of 1/2 and a y value of the square root of 3 over 2. To finish the first section of the unit circle, we have our first quadrantal angle, and that's at 90 degrees. My quadrantals are my pi over 2's. Okay, and this time the x value here is 0, and the y value is 1. Okay, so that's the first quadrant of the unit circle, and the first quadrant of the unit circle is the most important, because after this it kind of just repeats itself based on the reference angle, right? And the only difference is going to be whether it's positive or negative. And that's based on the quadrant you're in. So in quadrant 1, we have positive x and positive y. In quadrant 2, we have negative x and positive y. Quadrant 3, negative and negative. And then quadrant 4, positive and negative. Okay. So the easiest way to kind of work your way around the unit circle is to pick one and kind of count your way through, okay? So let's start with the 90 degrees. That's always kind of the easiest to start with. So I'm going to add another 90 degrees, and that's going to put me at 180. Okay. And to get the radian measure that goes with that, I'm going to add a pi over 2, because pi over 2 is 90, right? So pi over 2 plus pi over 2 would be 2 pi over 2, which gives me pi. And my ordered pair for this point would be -1, 0. Adding another 90, that would give me 270. So 2 pi over 2 plus a pi over 2 would give me 3 pi over 2. And that would be the ordered pair 0, -1. Adding another pi over 2, adding another 90 degrees, right? That would put me at 360, which would be 4 pi over 2, which would give me 2 pi. And again, that ordered pair there would be 1, 0. Now, doing that same process, we're just going to kind of pick the next one and then work our way around. So let's do the pi over 4s. So if I add a 45, that puts me at 90. I already have that taken care of. Add another 45, and that puts me at 135. And if I think about adding pi over 4s, pi over 4 plus pi over 4 would be 2 pi over 4, which would be pi over 2. Add another pi over 4 would give me 3 pi over 4. Okay, the pi over 4s have the ordered pair square root of 2 over 2, square root of 2 over 2. So now I just need to make sure I get the right signs. So quadrant 2, I have negative and positive. Okay, the coordinates, again, the numbers aren't going to change. It's just whether it's positive or negative based on the quadrant you're in. Add another 45, or add a pi over 4, right? That would give us 180 and 4 pi over 4, which would be pi. So I already have that taken care of. Add another 45. That would put me at 225. Okay. And if I'm at 4 pi over 4 here, add a pi over 4 would put me at 5 pi over 4. Okay. Square root of 2 over 2 is still the x and the y. I'm just in quadrant 3, so this time x and y are both going to be negative. Add a 45, that puts me at 270. If I added pi over 4, it'd be 6 pi over 4, which would be 3 pi over 2, so that's already taken care of. 6 pi over 4 plus pi over 4 would be 7 pi over 4. 270 plus 45 would give me 315. X is positive, y is negative, so positive, negative. Okay. And then going one further, adding a pi over 4 would give me 8 pi over 4, which would be 2 pi. Adding 45 degrees would give me 360. And I already have that taken care of, so the 45s are done now, the pi over 4s. Now, we're going to kind of take care of the 30 and the 60 kind of all at once, right? And we're going to do that by adding 30s or pi over 6s. And that'll take care of both of these as I go around the circle. So, if I start with pi over 6, if I add pi over 6, that gives me 2 pi over 6, which is 1 pi over 3, which is here. Add another pi over 6. That'd be 3 pi over 6. Add another pi over 6. That would be 4 pi over 6, which would be 2 pi thirds. Okay. And let's just go around and take care of the radians. So that was 4 pi 6. Add another pi over 6, and that would be 5 pi over 6. Add another pi over 6, 6 pi over 6, which would be pi, right? It's already taken care of. 6 pi over 6 plus pi over 6 would be 7 pi over 6. 8 pi over 6 would become 4 pi thirds. Then we would have 9 pi over 6, which is already taken care of, with 3 pi over 2. Then we would have 10 pi over 6, which would be 5 pi thirds. And then 10 pi 6 plus pi over 6 would be 11 pi over 6. And then 12 pi over 6, which would be 2 pi. Doing this same thing with the 30 degrees. So 30 plus 30 would give me the 60. 60 plus 30 would give me 90. 90 plus 30 would give me 120. 120 plus 30 would give me 150. 150 plus 30 is 180. 180 plus 30 is 210. 210 plus 30 would be 240. 240 plus 30 would be 270, which is taken care of. Add another 30 would put me at 300. And then 330. Okay, so the 30 and the 60, those are kind of related, right? Because they both come from that same special right triangle. It's just whether or not the reference angle is 30 degrees or 60 degrees. Now we just need to take care of my x and y, my coordinates, right? So let's do the pi over 6s first. So the pi over 6s are square root of 3 over 2 for the x and 1/2 for the y. So let's just make sure we get the right signs. Quadrant 2 is negative x. So negative square root of 3 over 2, positive 1/2. Quadrant 3, they're both negative. So negative square root of 3 over 2, negative 1/2. And quadrant 4, the y is negative. Okay. Taking care of the pi over 3s, I have 1/2 and square root of 3 over 2. So negative, positive, negative, positive, negative, negative in quadrant 3. Positive, negative, quadrant 4. All right, so that is a completed, fully written out unit circle with everything, radians, degrees, and coordinates. This is honestly probably one of the most important things that you need to know moving forward into calculus. You need to spend time and actually memorize this thing. Make sure you understand the pattern. We'll talk more about the patterns in class together. But if you don't spend the time to memorize this, and I understand that you're at home and you'll have this in front of you all the time, right? If you don't spend the time to memorize this when you get to calculus next year, whether that's here at Champ or if you're heading to college and you're going to end up taking college math, if you don't have this thing memorized, you are not going to have a good time because it's not going to be in front of you. So if you're planning on doing anything after pre-cal, you need to make sure that you actually spend the time to know this, memorize this, and understand this. Because like I said, this is probably the most important topic in the most important unit that we do all year in pre-calculus, okay? Now, let's look at using my unit circle to find some exact values. Okay, so this is why we need to know the unit circle, okay, and that is for evaluating my trig functions at these special points. So, since the unit circle is kind of fresh in our minds, I'm going to approach this kind of the longer way to kind of show you where we're getting and how we're figuring out what these values are. Eventually, you guys will have the unit circle memorized and you'll be able to just tell the sine of 240 is negative square root of 3 over 2. Like, you'll just be able to do that. But for right now, since we're just starting with this, I want to find where 240 is at. So if I draw a little xy plane here, here's 180. So 240 would be right around here, right? So there would be my rotation. Okay, so 240 degrees of rotation. So I want to identify the reference angle here, so that way I can relate it to quadrant 1, okay, of my unit circle. So 240 would have a reference angle, 240 minus 180, of 60 degrees. So I want to think about my pi over 3s on my unit circle, right? So when I go up here, I want to think about these guys. And they have the ordered pair 1/2 square root of 3 over 2. So I want to identify what trig value I'm evaluating. So whether I'm dealing with x, y, and then I want to figure out what quadrant I'm in for the sine. So I'm in quadrant 3. So that means that this is negative, and I'm dealing with sine, which we said was y. So I want the y value of my pi over 3s in quadrant 3. So I want it to be negative. So the sine of 240, the y value at 240 degrees is negative root 3 over 2. Okay. All right, let's look at the next one. So cosine of 315. So 315 is going to be in quadrant 4. Okay. Quadrant 4, so it's going to be positive x, negative y. So let's figure out what this reference angle is. So if I did 360 minus 315, that would give me a reference angle of 45 degrees. So that means I'm dealing with my pi over 4s. And pi over 4s have square root of 2 over 2 as the x and the y. So I want to identify my quadrant, which I already did. So I have positive, comma, negative. And then I want to figure out what trig function I'm evaluating. I'm evaluating cosine, and cosine is x. So x in quadrant 4 is positive, square root of 2 over 2. All right, let's look at a tangent. So 135, that's going to fall in quadrant 2. Okay, so that means that I have negative, positive, negative x, positive y. Okay, so that is a reference angle of 45 degrees, right? 180 minus 135 gives me 45 degrees, okay? So that means I'm dealing with my pi over 4s, which again has the ordered pairs square root of 2 over 2, square root of 2 over 2. This time I'm looking at tangent though. And tangent is sine over cosine. So y over x. So I'm in quadrant 2. X is going to be negative, y is going to be positive. So the square root of 2 over 2 all over, so that's the y, negative square root of 2 over 2. So my denominators here would cancel, right? Keep, change, flip, if that's easier for you to think about it that way. And I would get negative square root of 2 over square root of 2, which would give me negative 1. Now, some of you might have also noticed that you had the same thing on top and bottom, right? So if you just did the whole thing as a division, right, it's all going to cancel out and leave us with negative 1. All right, for the sake of time, there are more problems here, and I'll post the key with them completed if you want to try those on your own and check your work. Real quick, just for problems like this, remember, negative thetas are clockwise rotation, okay? Now let's look at some of these in radians. Let's look at the functions we didn't do. So let's look at a secant problem. So let's jump to number 4. So I want to kind of do the same type of thing here. I need to figure out what quadrant I'm in, and then kind of go from there. So 2 pi over 3, if I count by pi over 3s, 1 pi over 3, 2 pi over 3. So that means I'm going to be in, oh, I missed, quadrant 2. Okay. And the easier thing with radians is that you can tell what the reference angle is just by looking at your denominator. In this case, I have 2 pi over 3. That means my reference angle, pi over 3. Okay, so I'm dealing with pi over 3s in quadrant 2, so that means that I have negative comma positive. Pi over 3s have the ordered pair 1/2 root 3 over 2. And I'm dealing with secant. And remember, secant of theta is 1 over x, or 1 over cosine, right? So I would have negative, because it's in quadrant 2, so 1 over negative 1/2. And if you were to keep, change, flip, or realize you're dividing by a fraction, so it's multiplying by its reciprocal, I would get 1 times negative 2, which is negative 2. Let's look at number 5. Let's deal with a quadrantal angle. So if I think about my unit circle, here is where pi is, right? And it's asking me to find cosine. So cosine is my x value at that point. So that would be negative 1. Cotangent. Let's do a cotangent. Number 2. So let's count pi over 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay. Again, reference angle is your denominator, so we want to think about my pi over 4s. So square root of 2 over 2, square root of 2 over 2, and I'm in quadrant 4. So that's going to be positive comma negative. So cotangent is the reciprocal of tangent. Okay, if tangent is y over x, then cotangent is x over y. So plugging in, I would have positive x, so square root of 2 over 2, divided by negative y. And again, same thing top and bottom. I just have to take care of that negative, so I would get negative 1. And again, there's a bunch of practice problems here for you to try. I'll include them on the key if you want to check them out there. And we'll go over more of these in class, but I don't want to spend too much more time on this because it's taken a while. The last little part to talk about is just describing the quadrant based on what it gives us. So it's always going to give you two pieces. And the way I like to do these problems is I make a XY plane. And I start with the first piece. So the first piece says sine of theta is less than 0. So that means that y is less than 0. And that happens here and here, right? Below the x-axis. So y would be negative when it's less than 0, right? Then I look at the second piece. Cosine of theta is greater than 0. So that means x is greater than 0. X is positive, and that happens here and here. So you're looking for the quadrant that has both check marks. So for this problem, we would have quadrant 4. All right. First piece, tangent is greater than 0. So that means when I do my division, y over x, I get a positive number. So that means that x and y have to have the same sign. So that means that it's either positive, positive, or negative, negative, right? Negative divided by negative would give me positive, making tangent greater than 0. Cosecant less than 0. Cosecant is 1 over y. Okay, less than 0 means y has to be negative, which would be here and here. Look for both check marks, so this would be quadrant 3. Secant greater than 0, so that's 1 over x. So x is positive here and here. Cotangent greater than 0, x over y. So again, same signs. So positive, positive, or negative, negative. So this would be quadrant 1. Last one real quick. Cosecant greater than 0, so 1 over y. So y is greater than 0 here and here. Cosine less than 0, so that's x is here and here. So that would be quadrant 2.